Hello again, everyone. All right, so this is the last lesson for Unit 1 before you actually start looking at the review and start preparing for the exam. So this last lesson is solving inequalities. So this is very similar to solving equations. So if you were good with 1B, then you will be perfectly fine on this one, hopefully. If you were really iffy and really kind of scattered on 1B solving equations, I would highly recommend going back and at least just watching and listening again or reading through the note key before you even start this one. Because if you had trouble with solving equations, this one's going to be pretty tough as well. So 1B and 1D go pretty hand in hand, I will say. All right, so just kind of as a refresher, so we're going to solve these two equations. So we have 3x equals 18. So we have 3 times x, and we want to solve for x. So I need to get x by itself. So because I'm multiplying, oh my gosh. So because I'm multiplying, I'm going to divide by 3. So the 3's here, they will simplify. So if you remember, addition and subtraction is 0 out. Multiplication and division is simplify. So I'm going to have x equals 18 over 3, which gives you 6. All right, looking at the next one. So remember, whenever you have the variable on both sides, you want to move the smallest variable first. So that means between 4m and m here, you only have one m here. So this is the variable that you're going to move to the other side. So because it's positive, you want to do the inverse. You want to do the opposite. So I'm going to subtract it on both sides. So 4m, and I take away one of them. So 4 minus 1 gives you 3m minus 5 equals 8. So these m's here, they 0 out. So next thing is now undoing any addition and subtraction. So remember, the 3m here, those are being multiplied, but m minus 5, that's addition and subtraction. So this minus 5 right here, I have to do first. So because it's subtraction, I'm going to undo it by adding it. So I have 3m equals 8 plus 5, which gives you 13. 0 out. So now you want to divide. So you're going to have 13 over 3, which cannot be simplified. So just leave your answer as 13 over 3. So the 3's over here, simplify. So do not change it to a decimal, just leave it as 13 over 3. That is the exact answer that we want. Remember, decimals are essentially dead to us. We only want fractions unless the problem calls for decimals. Okay, so we're essentially going to be doing the same thing, but now we're going to be thinking of it in terms of inequalities. So here's the thing. Your brain is actually already hardwired to think in terms of inequalities. You just probably don't realize it. For example, if you go to a gas station, if you have 20 bucks to spend, ask yourself this: can you spend more than 20 bucks? Well, no, you only have 20 bucks to spend. You don't have enough money. Can you spend less than 20 bucks? Like just because you go to a store and you go in with 20 bucks, do you have to spend all 20? No, you can spend 5 bucks, you can spend 3, 17.50, however much. That money intrinsically in that case is an inequality. You can spend less than or equal to $20. So those kind of situations are inequalities, and we're already hardwired to think in terms of inequalities. We just don't realize it necessarily. So for this one, we're actually going to be graphing these inequalities as well, because the graphs are going to help us visualize what all the different solutions can and will be. So looking here, we have 4 different types of inequalities. We have less than or equal to, greater than or equal to. So less than, greater than, less than or equal to, and greater than or equal to. So those are our 4 different inequality signs. So here's the thing. If you cannot be equal to it, so it has to be strictly less than or strictly greater than, we're going to be using an open circle. However, if we can be equal to it, so like in before with the $20, we can spend $20 or less. That is when we're going to use a closed circle. So a circle, but it's going to be filled in for a graph. This is why I failed pre-K. Just kidding, I didn't fail pre-K. Can't color inside the lines, everything's fine. There we go. I missed a spot. There we go. Okay, anyways. If you're like me, you probably can't color in the lines. It's fine. Okay, so if you can be equal to it, it's a closed circle. If you cannot be equal to it, it's an open circle. So remember, the line below, that tells you if it's an open or closed. So now looking on the other side. So this is going to tell you where we're going to put our arrow. So here's the easy part for this one. Literally make an arrow out of your inequality signs. So if I look up here where it says shade left, I can make an arrow out of the inequality sign and it will tell you which way to shade. So go left. Same thing over here. If it's less than, you want to go left. And then conversely, if it's greater than, you want to shade to the right, make an arrow pointing to the right. Okay, so the inequality signs will definitively tell you which way to put your arrow. Okay, now this is only for what I call the LOL rule. So what LOL means is the variable or the letter has to be on the left side. So just like before in 1B, when I was saying don't be that person that writes the variable on the right side, this is why. So I do the LOL rule, letter on the left. Okay, so that'll be more apparent in a few problems later on. All right, so we're gonna go ahead and start solving these. So when we're solving these, we solve them the exact same way you would solve an equation. You're still doing your inverse operations, you're still doing SADMEP, you're still doing addition, subtraction first, multiplication, division next, any exponents, which we don't have to worry about, in parentheses, we don't have to worry about yet. Okay, all right, so I have t plus 19 less than 23. So what I'm gonna do is I'm going to subtract 19 first. So the 19s, they will zero out. So I'm going to have t less than 23 minus 19, which gives you 4. So once you get to your answer here, this is where you can start addressing the rest of the details. So what I mean by that is you want to ask yourself those two questions. Is it open or closed? And do I shade right or left? So I always answer these two questions as part of my work. So first one, is it open or closed? Well, I cannot be equal to it. So that tells me it's going to be an open circle. And then you want to look to see which way the arrow is going to face. So I just make an arrow out of my inequality sign and it's going to the left. So I say open slash left. So I take this as part of your work. So remember, I require the work shown on all your homeworks. So I would expect to see this on your homeworks. All right, so now you actually have to graph it. So if you notice there's literally nothing on the number line, you actually have to fill it in verbatim. I don't give you any hints as to where the answer might be. You have to fill everything in. So what I'm gonna do is I have t less than 4. So I have an open circle. So I'm gonna go to the middle of my number line. I'm gonna put an open circle. And underneath, I'm going to label 4. So here's another small detail that is important. I do require that you put 2 below and 2 above. So when I say 2 below, 2 above, 2 below would be at 2, 2 above would be at 6. So you're filling in part of the number line. So once you get that, then you can do your arrow. So we're going to the left. So what I do is I go up a little bit, then arrow directly to the left. So make sure you're using as much of that number line as you can, because what I see happen a lot, and it drives me insane, is whenever y'all do this. Like, what are you doing? Like, hello? All right, anyways. Use the entire number line. Okay, so that's it for that one. All right, now I'm going to do the next one. All right, so now you have 4w minus 3 less than or equal to 5w. So if you notice, you have the variable on both sides. So remember, move the smaller variable. So between 4 and 5, 4 is your smaller one, so I'm going to move that one. So I'm going to subtract 4. So I have negative 3 less than or equal to 5 minus 4 gives you 1w. So here's the thing. This is where LOL is going to come into play. If you look, the variable's on the right side. We want it to be on the left side. So what I'm going to do is I have to do a little bit more rearranging. So I'm going to put w and negative 3. So when you flip the sides, notice how your inequality sign is open towards your w. So it needs to be open towards your w. So notice that when I did the letter on the left, it actually flipped your inequality sign. So be careful and be cognizant of where your inequality sign is facing. I've seen a lot of people where they flip the variable, but they forget to flip the inequality sign. So this is what we really want. All right, so with this, because I can be equal to it, this is a closed circle. And I'm gonna make an arrow out of my inequality sign, so that's facing to the, I can't draw, it's fine. That's facing to the right. All right, so just like before, I'm gonna go to approximately the middle of my number line. I'm gonna draw a closed circle, or try to. Close enough. So I am looking at negative 3. So you have to do 2 below and 2 above. So 2 below negative 3, so to the left, gives you negative 5, and 2 above gives you negative 1. And you want to shade to the right. So I'm going to go up and over. There we go. So I recommend just going up and over. It's just easier to see and easier to visualize, just because I've seen people put like the smallest, tiniest line on the number line and it's hard to see sometimes. So I just highly recommend and ask that you just go up and over. All right. Next. So here we have d divided by 2 greater than or equal to negative 1. So if you remember, this is the same as division. So to undo division, I'm going to multiply. So I'm going to multiply by 2. So those are going to simplify. So I have d greater than or equal to negative 1 times 2, which gives you negative 2. So ask yourself those 2 questions, open or closed, then right or left. So because I can be equal to it, this is closed. Then make a arrow out of your inequality, or try to. Why am I so terrible at this? There we go. So that's going to the right. So just like before, closed circle, approximate in the middle, make sure it's closed. I can't color in the lines apparently. So this is negative 2. So 2 below, which is negative 4, 2 above, which is, that's not a 0. That's a 0. All right, now you want to go to the right. So up and to the right. Boom. All right. So for this next one, this is when some extra little nuances and tricks come into play. Okay, so whenever we are multiplying or dividing by a negative, we have to flip the sign. So this is similar to when we were doing the LOL rule up above. So I'm going to solve it just like I normally would. However, we have -2 times m. So I need to divide by that -2 to get m by itself. So what this rule says is because I'm dividing by a negative, when I divide and those simplify, I just have m. However, now I have to flip the sign. So instead of it being greater than, now it becomes less than. Oh no. There we go. I cannot draw. There we go. So we have -6 over -2, which simplifies to +3. Okay. So remember, anytime you multiply or divide, it applies to both multiply or divide. You have to flip the sign. All right, so what that does is we have an open circle, and it's going to shade to the left. So if you make an arrow, it goes to the left. Okay, so open circle at 3, 2 below, 2 above, one to the left. Boom. There you go. Okay. So this is really similar to just solving equations. It's just adding that graphing component and it's adding the inequality signs. So there's only a few extra things that are new. The rest of this is pretty similar to 1B. Okay, so I will say whenever we get to word problems and applications, you have to utilize those context clues. So this is just a little matching thing. So just a little disclaimer here that these are not the only ways that is a terrible star. This is not the only way that inequalities can be worded in a problem. So you really have to use the context clues and really look at what the problem is asking. So these are just some examples. So if I want at least 5, I want 5 or more. So I want to be greater than or equal to. So those would be B, which is greater than or equal to. All right, if you want at most 5, so you want 5 or less. So you can be equal to 5, but you want less than 5. So this would be D. So less than or equal to. So I want greater than 5. So here's the thing. I didn't mention that I could be equal to 5. So I only want something that's bigger than 5, which means this would be C. And then if I want something that's less than 5, I want something that's strictly less than 5, which cannot be equal to 5. So this would be A. So just really use those context clues in those word problems because the way that some of them are worded can be kind of tricky here and there. But all right. So now we're gonna look at some special cases. So just like before. iMovie, leave me alone. Okay. So solve it just like before. So I'm gonna distribute. So I'm gonna have 8C plus 2 less than 1 plus 8C. So what I'm going to do next is I want to get rid of the variables. So I'm going to subtract 8C. So these are going to zero out. So that leaves you with 2 less than 1. So ask yourself, is 2 less than 1? If you have to say it out loud, say it out loud. So 2 is not less than 1. So that means this is false. Which if it's false, that means there is no solution. So this implies that there is no graph. You can't graph no solution. Moving on. All right, so once again, start with distributing. So we have -6 plus 6 greater than or equal to -6 minus 9. I'm going to distribute to the second term as well. I almost did. All right, so we're going to add 6 on both sides. That is correct. Okay, so these are going to zero out. So we're going to have 6 greater than or equal to -9. So 6 is greater than or equal to -9, so this would be true. And this would be IMS, or all real numbers, or infinitely many solutions, whichever one you want to call it. Okay. So in order to graph IMS, that's literally saying that any value is a solution, no matter what I plug in, -10, +10, 25, -4, -2.65, like no matter what you plug in, it's going to work. So what that means is it's literally just an arrow on both sides. Okay. All right. I apparently was feeling very cruel and unusual, so I came up with this monster. I don't know why. Everything's fine. All right, so first things first, distribute. So 5p plus 4p minus 24 less than or equal to 8p minus 24. All right, now I'm going to combine like terms. So I'm going to combine the 5p and the 4p. So I'm going to have 9p minus 24 less than or equal to 8p minus 24. All right, so now I'm going to move the variables. So between 8 and 9, 8 is my smaller one, so I'm going to move the 8. There we go. So I'm going to have p minus 24 less than or equal to -24. Now I need to get p by itself, so I'm going to add this 24. So I have p less than or equal to, so these 24s here, 0 pair, so they 0 out. And then also here, they 0 pair and 0 out. So I have p less than or equal to 0. Now here's the thing. This is not actually a special case. This is actually just a traditional any other problem. If it ends in true or false, those are the special cases. This is not a special case. So in this, we have a closed circle, and it goes to the left. So approximate to the middle, make sure it's closed, 0, 2 below, 2 above. I apparently cannot draw a line, everything's fine. And to the left. All right, so there's that one. All right, so now we're gonna get into some word problems. So I will not lie. These are just annoying. I don't know how else to say it, but they are necessary. You are probably gonna see some of them on star, which is unfortunate, but it's okay. All right, so the maximum weight allowed on an elevator is 950 pounds. The 5 people already on the elevator weigh about 780 pounds. To be able to ride the elevator safely, what's the maximum weight the 6th person can weigh? All right, so there's a 5-step process for these, and I wrote out the steps for you for the first one. So the first thing you have to do is you have to define the variable. So I tell you guys to look at what's the ultimate question. So when I say the ultimate question, that's usually at the very end. So it wants to know what is the maximum weight the 6th person can be or weigh. So we're looking at weight. So I'm looking for an unknown weight. So I'm going to say x equals the unknown weight. or you could just say weight, same difference. So now we need to actually write out the inequality. So this is where, as mentioned before, you really got to look at the context. So the maximum weight. So we cannot go over the maximum weight. So the maximum weight on an elevator is. So the key word here is, that tells you we can be equal to it. So we can be a max of 950. So there's already 780 pounds on the elevator. So what this translates to, this is where you have to translate from English to math, because math is literally a language. So you have some unknown amount of weight plus the 780 pounds that already exist on the elevator, and you can have a maximum of 950 pounds. So if you can have a maximum, that tells you you can have to be less than or equal to it. You can have 950 pounds on the elevator, but no more. So once you actually come up with that inequality, then you can solve it. So this is step 3. So you're going to use your inverse operations. All right, so we're going to subtract 780 on both sides. So these are going to zero out. So you're going to have x less than or equal to 170. So here's the thing. Once you get there, now you got to actually check it. So I'm going to take that 170 and I'm going to plug it in. So 170 plus 780 less than or equal to 950. And you just want to check to see if this is going to give you a true or a false statement. If it gives you a true statement, you're good to go. If it gives you a false statement, you need to back up. Something happened. So when I add 170 and 780 together, you get 950. Less than or equal to 950. So here's the thing. 950, it's not less than 950. However, it is equal to it. So because of that, it works. So the next part is you have to answer it in a sentence. So here's the general rule of thumb for math. If I give you words, I want words back. So if I give you a word problem, I'm going to want my answer in a sentence, or in words. So you have to translate this back from math now to English. So what this means is the maximum weight So the maximum weight of the sixth person can be 170 pounds. Okay? It doesn't have to be a 3-page expository essay on anything, like literally just a sentence. Okay? And it doesn't have to be this sentence exactly, as long as it's conveying the same information and saying the same thing, it's good. Okay? So that's when the problem's broken down step by step. So as per usual, not all the problems are going to be broken down like that. All right, so looking at this next one. So twice the sum of 4 and x is less than negative 16. Find the possible values of x. All right, so when it says twice the sum, this means I'm going to do 2 times the sum of that value. So I want 2 times the sum of 4 and x. So I'm going to add 4 and x together, and then I want to multiply that by 2. Ooh, I didn't do my first step. Shame on me. So I need to define the variable. So in this case, the ultimate question, find the possible values of x. So x represents possible values. Now I need to write my inequality. So I have twice the sum of 4 and x. So twice the sum of 4 and x. So 4 and x, that's the same thing as saying addition. And it is less than negative 16. less than negative 16. I didn't say anywhere in that problem that I could be equal to it, so you don't put the equal sign. So so that was step 2. Step 3 is now you actually solve it. So I'm going to distribute. So I have 8 plus 2x less than negative 16. So I'm going to subtract 8 on both sides. So 2x less than negative 16 minus 8 gives you negative 24. Divide by 2. So x less than negative 12. Okay, so that was step 3. So now you actually want to plug it in. So here's the thing. X must be less than negative 12. So when you're plugging it in, that's not a 6. When you're plugging it in, remember, we can't be equal to negative 12. It has to be less than negative 12. So what that tells you is instead of plugging in negative 12, plug in the next value right next to it. That's less than. So plug in negative 13. And then you want to see if it's true. Because if you plug in negative 12, it's not going to work. All right, so now I'm going to check. So 4 and negative 13, when you add those together, you get 2 times negative 9. So 2 times negative 9 gives you negative 18. And negative 18 is less than negative 16, which means it works. So let's see what happens if I plug in 12. So 2 times 4 plus a negative 12. So just real quick. So you're going to get 2 times negative 8 less than negative 16. So you're going to get negative 16 less than negative 16. That is false. It doesn't work. That's why you have to plug in a value that's actually less than negative 12. Okay. So this is actually what you would use to check, not this. So once you checked it, then you can write your final answer in a sentence. So you're translating your answer from step 3 into a sentence. So the possible values of x So the possible values of x are less than negative 12. So once again, I don't need a full essay, just a sentence, an actual sentence. Okay, so I will say 3 and 4 are very similar. There's just some little bit of vocab that needs to be emphasized. Let me get my calculator for this one. All right, so Terrence wants to make and sell paintings to earn money. The tools he needs cost $48. He also needs $2 in supply for each painting. If he sells the paintings for $6 each, how many paintings must he sell to make a profit? Okay, so first step, you have to define the variable. So you're looking for what we call the ultimate question. So which is typically at the end of the problem. So how many paintings must he sell to make a profit? Okay. So that means I'm going to make x equal to the number of paintings. All right. Now I want to actually write out my inequality. So here's the thing. You can actually do step 3 when you're solving. You can do it perfectly well, but if you write the wrong inequality, you're already pretty much setting yourself up to fail. So step 2 is actually the most important step. You have to be able to write it out correctly. So he wants to make and sell paintings to earn money. So the tools he needs costs $48. So here's the thing. If it costs $48, this is an expense. That's not money in his pocket. He's losing that money. So this is a negative $48. So he also needs $2 in supplies for each painting. So each painting here. The key word here is each. Because for every painting he does, he has to spend that $2. So what this translates to is it's minus 2x, because he's losing that money for every painting. So this is also an expense. However, here he sells the paintings for $6 each. So he sells them. So if he's selling them, this is money in his pocket. He's getting this money back, $6 each. So it's going to be a positive 6x. So we want to be able to write this all in an inequality now. Now, the last part is also very important. And it simply just says to make a profit. So when I say make a profit, that in business terms literally just means you can either make a penny, you can make $200, you can make $1,000, as long as you're not ending up with $0 or you're not ending up in debt. So a penny is still a profit. It's not a good profit, but it's still a profit. So what this means is you want to be strictly greater than 0. So you want to just compile all that information into one blob, into one inequality, and solve it. So I'm going to start off with the profit. So he actually makes $6 per painting. He has to buy $2 in supplies for each painting, so it's an expense. And he actually spends $48 on the paintings or the supplies for the paintings itself. And he just wants to make a profit. So that just means greater than 0. So this is your inequality that you want to solve. All right, so I'm going to combine like terms. So 6x minus 2x, which gives you 4x, minus 48, greater than 0. So I'm going to add 48. So you have 4x greater than 48. Now you want to divide by 4. So x greater than 12. So here's the thing. You want to sell greater than 12. Can you sell 12 paintings and get a profit? No, because you cannot be equal to 12. So because I have to be strictly greater than 12, I'm going to plug in 13. So when I check, I'm going to do 4 times 13 minus 48. I'm going to see if that's going to be greater than 0. So 4 times 13, so that'd be 52, minus 48, greater than 0. 52 minus 48 gives you 4, greater than 0. It works. So it pans out. So now I need to write my sentence. So what's his name? Terrence. Terrence. I can't spell. Yes. So must sell Okay, so here's the thing with the sentence. You actually have some flexibility on how you write this sentence. So even though he must sell more than 12 paintings to make a profit, you could also get away with saying Terrence must sell 13 or more paintings to make a profit. So you will have some flexibility on how you write the sentence. However, when it comes to the answer in terms of an inequality, This is what we're going to be looking for. That is also technically a valid solution. However, the problem calls for x strictly greater than 12. So just keep that in mind. All right, so Terrence wants to make and sell paintings to earn $120 for a new jacket. So it's the same idea, same values and everything. It's just now he wants to be able to afford a jacket. So everything else is the same. So I'm literally going to copy and paste because I can. So x still represents the number of paintings. So I'm actually going to copy this equation over and just modify it. So here's the thing. Instead of just making a profit, now he wants to earn $120 for a jacket. So I'm just going to modify this equation. So I'm going to get rid of this part over here for the profit. When you're purchasing a jacket, you can spend exactly $120 and still afford the jacket. If you have $125, you can still afford the jacket. So he just has to have $120 exactly. So it can be greater than or equal to. So I'm going to solve this one just exactly like I did before. So combine like terms, you get 4x minus 48 greater than or equal to 120. Add 48. So 4x greater than or equal to 168 divided by 4. So x is greater than or equal to 42. So I'm going to check it. So 4 times 42 minus 48. So 4 times 42, 4, 168 minus 48 greater than or equal to 120. I'm going to combine 168 and 48. So 168 minus 48, that gives you 120 exactly. Greater than or equal to 120. That works. All right, so now we got to translate it from math back to English. So what this means is so Terrence must sell at least 42 paintings. So Terrence must sell at least 42 paintings in order to be able to buy the jackets. So once again, the sentence doesn't have to be exactly what I have. It could be any variation of it as long as it's conveying the same information. Okay. So for the last one, so Jesse makes $9.75 an hour working at Half Price Books. He wants to buy the newest iPhone priced at $7.99. So write and solve the inequality describing how long Jesse will have to work in order to be able to purchase the iPhone. So in this case, your first step, your ultimate question, how long will Jesse have to work? So I'm going to say X represents, or you don't actually always have to use X. So in this case, since we're talking about hours, I'll say H equals hours worked. You could use X, you can use R, you can use S, you can use happy face, sad face, literally whatever works. Okay, so he makes $9.75 an hour and he wants to be able to afford the iPhone at $7.99. So if you work 9 and you earn $9.75 per hour, you're going to be multiplying. So you want to be able to afford an iPhone that costs $799. So think of the inequality sign here. Do you want to earn more than the phone or do you want to earn less than the phone? In order to afford the phone, you have to earn more. So it has to be greater than or equal to. So this is where you can use the calculator, or actually I'll show you Desmos. Or actually here. What you can do is you can actually split screen. If you don't know how to split screen, press and hold, bring up the dock. Let's see if it works. Oh, it doesn't show very well on here. Dang. Oh well. Okay, anyways. Now it's not going away. Well then. All right, so you can do in Desmos, you can actually plug in 799 divided by 975, or on a calculator, it all works the same. So I'm not a human calculator, so I'm using my calculator for this one. So x greater than or equal to 81.9487. I always use 4 decimal places. I know it sounds like a lot, but that's actually typical. Okay, so here's the thing. Whenever you're working, we don't account for these values. So what this actually translates to is, because we need to work more, what we do here is we essentially round up. So x greater than or equal to 82. Okay, so now you want to plug it in. You want to check. So I'm going to do 975. I'm going to multiply by 82. I want to see if it is greater than 799. So if I do 975 times 82, you get 799.5. Greater than or equal to, that's not 7. 799. So it works. So he has to work 82 hours, which is a lot. So of course, in these situations and problems, we're completely ignoring taxes and whatnot. But all right, now we got to translate this to words. What's his name? Jesse, her name, their name. So Jesse must work at least 82 hours to buy the new phone. So these are actually some pretty good applications too. Some of these can actually apply to you guys if you're saving up for something. Especially when you start saving up for a car, or if you're saving up for a new phone. Some of this stuff is actually really real life applicable. Just saying.